Hey, it's Professor Davis here with you, and I want to take a few minutes to talk about multivariable and statistical thinking. To start to get you thinking more statistically and maybe a little bit less algebraically. Now, some of the graphs I'm going to talk about here are, I did, and most of the graphs, though, come from a collection from a column in the New York Times called What's Going On in This Graph. So if you want to see more of these, you can go to, you can just search for that column, and you can see a large collection of about 40 or 50 graphs. They're all kind of the same type. And so one of the guidelines that we have in statistics that's relatively new is multivariable thinking. In algebra, a lot of the times we think about everything in terms of X and Y, two variables. So the graphs you're going to see have more than two variables. So we're just going to talk about them and look at some of their characteristics. So let's take a look at the first one here. Well, this graph has four musical artists listed: Rihanna, Drake, Taylor Swift, and Luke Bryan. And so that's one of the variables. And we also see the listener density. These graphs all come from YouTube analytics, and if you've made a video on YouTube, you can get the same sort of data where you can see that the density of your listenership is shown geographically, and that's really the third variable here, the geographic location. So let me just pose a couple of questions on these graphs, and you can kind of think about them for a minute. And if you take a look at the legend at the bottom here, we can see that the darker the red, the higher the listener density. The more people within that geographic area are listening to that artist. So if I would ask you, for example, which artist appears to be the most popular in Appalachia? Well, you can take a look at it. You can probably see right through here. Where Appalachia is, it's very dark, so that would be more of Luke Bryan's area. And if I would ask you, for example, which of these artists would be most popular in the Rocky Mountain region, well, if you look around here, and you probably see would be Taylor Swift, because she apparently is popular in these states right around here. All right, so there you see three variables, and they're all shown in these graphs. Let's take a look at a few more here. Now, this graph has projected earnings for different occupations. So the variables involved here would be those occupations you see listed on the left. And the projected earnings you see, I know this is over career earnings, and those are listed on the bottom. And then the percentile rank, where you rank according to these other occupations in general. So we can see, for example, if someone has an occupation like in social work, for example, you see they're more on the lower end of the pay scale. The median career earnings would be somewhere around a little over $2 million. As opposed to, let's see, nursing, for example, you can see there their median projected earnings would be, well, about $3.25 million over their career. Or someone in chemical engineering, well, it looks like they're approaching the $4 million mark. So you can see the relative ranks in terms of the percentiles. The median would be the 50th percentile. We'll talk about that later on. And you can also see what the career earnings are. So let's take a look at a few more. Let's take a look at the next one. This next graph is called a scatter plot. It's a bunch of dots on a graph. And here we see three variables again. The number of mass shooters, that's highlighted there on the vertical axis. The number of guns in the country, that's labeled there on the horizontal axis. And then the third variable, well, that's the country names. You see that these dots are labeled. So this is a labeled type of what's called a scatter plot. All right, so we can see, for example, if we look at India, they have about 50 million guns in the country there, but very few mass shooters. Here would be 20 mass shooters, so it looks like they have less than 10 mass shooters. Contrast that with the Philippines, and you look at the Philippines, very few guns in that country, but it looks like it's just under 20 mass shooters. But you see there's one country that's much different than all the others here. You look up here at the United States, and you see it's much different than all the other countries in that it has both a large number of guns in the country and a large number of mass shooters. So the United States here is an example of what's called an outlier, a piece of data which is much different than all the other data. And again, we'll talk about that more in depth later on when we talk about descriptive statistics. This next graph is interesting in that it's kind of a pictogram. It has pictures on it. The variables here would be the percent of Americans saying a food is healthy. You see that on the horizontal axis. The next variable is on the vertical axis, the percent of nutritionists who say that same food is healthy. And then you see the pictures and the labels of various food types. So if we look down here in the lower left corner, oh yeah, by the way, you see this dotted line here. Maybe from algebra, you remember this. This is called the 45-degree line, sometimes called the identity line. That is where the Americans and the nutritionists agree on the healthiness of various food types. So, for example, we look down here and we see chocolate chip cookies. Well, very few nutritionists or Americans think that's very healthy. Same thing with French fries and ice cream. And then we look up here at the other end, and we see things like spinach and oranges and almonds. Most nutritionists and Americans agree those are very healthy. And then we have some values that are kind of off of the chart. For example, if we take a look at granola bars, we see here that about, a little over 70% of Americans think that food is healthy, but only about 30% of nutritionists, a little bit less than that, think so. And the reason would be, I would guess, that the granola sounds like it's a healthy thing, but really there's a lot of sugar and a lot of additives in it. All right? And then you see something like quinoa here, which a lot of Americans probably don't think is healthy, a little bit over 50%, but about 90% of nutritionists think it's healthy. The same thing goes with hummus. So here we can see the most interesting ones are the food items which deviate from this identity line. All right, next, here's a couple of graphs called histograms. They're a type of bar graph. And the variables involved here would be the ages of first-time mothers, and you see that on the horizontal axis. The percentage of each age being a first-time mother, that's on the vertical axis. And then we see the change in years, because we have these ages in 1980 and comparing that to 2016. So you see, if you look at 1980, you look at many of these first-time mothers were around 19, 20 years of age. So it's at its peak here, and then it tails off here to the right. Later on, we'll talk about this more. It's called being skewed right. All right. And if you compare that to 2016, well, if you take a look here, you do see some first-time mothers, about 6%, all right, have their first child in their about 19, 20 years old. But this is much flatter, right, when compared to the 1980 graph. We see the percentage of women having their first time births being in their late 20s here is just about the same as their late teens and early 20s. So we see the graph on the right is much more uniform across the top, sometimes called platykurtic. All right, so there we can contrast two different things over time. Now in this next graph, we see another map. This is called a distribution map when you take a look at different kind of phenomenon on a map like this. So here it's a map of states. Could be a county map, that kind of thing too. Now the variable here would be the population change, either positive or negative. If the population change is positive, it's purple, and if it's negative, you see it in red. All right. And then second is the size of the population change, and you can see these circles here are of various sizes. And then the third thing would be the geographic location. So let's contrast some of these here. We see that, for example, where we look in northeast Ohio, there's a huge dot of red, meaning the population change decreased over that time. All right. And the same thing with Detroit. You see there's lots of people moving out of Detroit. Contrast that with southern Florida, where you see a large blue area, where you see lots of people moving into there. Same thing with, notice here, southern California, the San Diego area, where you see lots of people moving in there. Same thing true over here in Arizona. You see lots of people moving in there. And so you see lots of change in population shown in this graph. Next, here's a graph that I made using StatCrunch, and I scraped this data from a website. And notice here the variables in this case would be the height of the roller coaster, that goes across the horizontal axis. The speed of the roller coaster in miles per hour, that goes across the vertical axis. And you see the different colors here for the different amusement parks. So you see generally, as you trace along these dots, the higher the roller coaster, the greater its speed. I guess that kind of makes sense in a way, doesn't it? And the one I highlighted is at the very top here, right here, this pink one, that's at Cedar Point. Try to think of what that one would be. That one is over what? Over 120 feet high, nearly 200 miles an hour. That would be Top Thrill Dragster, wouldn't it? So you can see here, 3 variables going for just some data that I scraped from the website. Well, this graph is a little bit different. It's a kind of an area map. The variables involved here would be the year. You see that on the horizontal axis here. The percentage of each source of electricity, and that's on the vertical scale. And then the source type. Notice here we have coal, nuclear, natural gas, hydroelectric, all right, and that kind of thing. So we can see here that before, at the beginning of the century, a little bit more than half of all the electricity that was generated came from coal. And then you see a change here about in 2005, 2006, where nuclear energy kind of came out of favor and natural gas became more popular. And if you may not remember back at that time, but there's a new drilling technique called horizontal drilling, sometimes called fracking, where that came very popular, and natural gas really kind of took off. And you can see that it perpetuated even more so, and you can see here in the late teens, around 2014, 2015, notice here that we now get most of our electricity, and that source being natural gas, more so than coal now. And I guess to note down here at the bottom, we see we get about 6% from wind energy, solar even less, and geothermal even less than that. Geothermal's been around a long time, so it's kind of interesting to see how little it's gained in traction. Well, one more graph I wanted to show you here. Here's a time sequence graph with, you can see here the variables here would be the year going across the horizontal axis. The percentage of students using various tobacco products, could be any tobacco product or in particular e-cigarettes. The type of product, as I mentioned, e-cigarettes or any type of tobacco product. And there's a fourth variable here, actually. The student grade. Notice here we have this segregated into middle school and high school students. So the most important thing to note here is the gain in popularity of e-cigarettes for some middle school students, but in particular the high school students. We see after 2017 the number of students trying e-cigarettes went from about 12% to over 20%. All right, and notice here it's almost parallel to those smoking both e-cigarettes and tobacco-based cigarettes. These lines are almost parallel. All right, same thing is true down here. So the it's clear from this that the use of e-cigarettes has really contributed to the use of tobacco among some middle school students, in particular high school students. So that was the idea here, to get you to start to think statistically and also in terms of more than one variable.